Okay, so it should be recorded now. So what I'm saying is today also we are going to see questions related to division, but the wordings of the question is going to be slightly different. Okay, so let's take up this example 9 from your NCERT book. Okay, this is chapter 2, polynomials, example 9. Now I want you people to read this question and think how this could be related to division. I've been talking about division, how this question is related to division. Just take a couple of minutes, read it, and just I will explain it after that. Yeah. So I want everyone to remember this type of question. They have given you a polynomial. What kind of polynomial is it? What should I call it? What kind of polynomial is it? It's a polynomial of degree 4. So you can call it as quartic or biquadratic polynomial. Okay. Quartic or biquadratic polynomial, and they're asking you to find all the zeros. Tell me, how many zeros will it have? Yes, if the degree is 4, that means it will have 4 roots, right? 4 zeros. Remember, they have given you the polynomial, and they have on what else they have given? Read the question completely and tell me.
Sir, out of all the 4 zeros for this biquadratic polynomial, they have given 2 of it. We have to find the rest 2.
Yes, exactly. That is what I was looking for. I want you to understand it very clearly that there is a quartic polynomial given. So since it is quartic, it will have 4 degrees 4. So it will have totally 4 zeros. So out of the 4, 2 of the zeros are already given to you, and I have to find the rest of the 2. So I want you to remember this type of question. Okay. Now, how do I do this? That I'm going to explain now. And this is very similar to division questions, very similar to what we did in the previous classes. But let's relate it to the zeros. How division is related to zeros. So for that, let's say there is a polynomial. It's given as px. It could be any polynomial, quadratic, cubic, whatever polynomial it is. And let's say it has zeros alpha and beta. Let's say this is quadratic polynomial itself. Okay, let's have a quadratic polynomial. Alpha and beta are the 2 zeros of this polynomial. Guys, I want everyone to join 5 minutes before the class, okay? Because this keeps distracting. So make sure everyone joins 5 minutes before the class. Okay?
Sir,
Yes, tell
good
me.
evening, sir. Sir, today in our class, Rayan champion competition was held, sir. That's why it was late.
Okay, that's fine then.
Okay,
Right.
sir.
Okay. So I am talking about this question over here. We have just started with this question, chapter 2, example 9. This is a new type of question which I want you to get comfortable with. Okay, so this is a new type of question in which a polynomial will be given to you. They will give some of its zeros and you have to find the remaining zeros. Okay, so particularly for this example question, this is a 4th degree polynomial. As you can see, degree is 4. So if this is a 4th degree polynomial, it will have a total of 4 zeros. Okay, and out of the 4, they have given two of its zeros. One of them is square root of 2, other one is minus of square root of 2. So two zeros are given and they're asking us to find the remaining two. So when you have this kind of question, it means that they are saying that somehow zeros are related to division or this polynomial. How do I do that? So let me give you a simple example first, and then we will come to the quadratic polynomial there. Okay. So let's say I have some quadratic polynomial, and alpha and beta are the two zeros of this polynomial. Okay. So if somehow they tell you that one of the zeros is 2, one of the zeros is 2, let's say alpha is equal to 2, then what it means is if you do x minus 2 and you divide your polynomial, let me take, hold on, let me take some very specific example. Hold on. Okay. Let me make up one example. Okay, so let my polynomial be x square minus 4x plus 3. Okay, this is my polynomial, and I'm telling you that one of the zeros of this polynomial is 1. 1 is one of the zeros. I want you to find the other zero. So whenever you know one of the zeros, what you can do is you can, right, if one of the zeros is 1 means when you put x equal to 1, this will make the polynomial 0, right? If you put x equal to 1, it will make this polynomial 0 because 1 is one of the zeros, right? So when you make this into a polynomial, what you do is you move this 1 to the left hand side. This will become x minus 1 equal to 0, right? Tell me if you are able to understand this.
Yes, sir.
So this x minus 1, this is also a polynomial, right? So this polynomial, I want you to call it as gx. And then what you do, very simple thing, is divide your polynomial px with gx and see what happens. Do that division. Px divided by gx and find me the quotient and remainder. You have that polynomial. This is a polynomial in front of you. This is your gx. Everybody knows how to do division. Do that very quickly and tell me what is the quotient and remainder.
X minus 3, sir.
So we complete the division. X into x will become x square, and x into -1 will become minus x. When we change the sign, this plus becomes minus, and the minus becomes plus. So these two become 0, and minus 4x plus x becomes minus 3x plus 3. So again, we have to multiply by minus 3, so that it becomes minus 3x plus 3. Now, there are two things to notice over here. When you did a division, I said that 1 is one of the zeros. With this 1, I made up this polynomial gx. And when I did a division with that, what is the remainder I'm getting? 0, right? I think you studied this in 9th standard also. Whenever you have a polynomial and you do a division with a linear polynomial like this, if the remainder is 0, it means x minus 1 is a factor of this polynomial. Remainder theorem, factor theorem. Does that ring a bell?
Yes, sir.
Okay. So it's very same idea, but I'm not counting on you people remembering that. That's why I'm telling everything from the beginning. Okay, so remainder is 0. It will always be 0. Whenever somebody says that 1 is one of the zeros, and if you do division with x minus 1, you are going to get remainder 0. And whatever is this remaining quotient over here, x minus 3, this is one of the other factors of this polynomial. So basically, your polynomial x square minus 4x plus 3, it can be written as x minus 1 into x minus 3. This is one of the factors. You know division algorithm, right? Everybody knows that. So this is what we are doing. Let me write it in terms of division algorithm only. Px is equal to gx into qx plus rx. So gx is x minus 1. Qx quotient, what did we get? X minus 3. And remainder is 0. So of course, x square minus 4x plus 3, it is going to be equal to x minus 1 into x minus 3. So you got the other factor, x minus 3, as a quotient. Can you now find the other 0 or not? By doing a division with x minus 1, when you divided this polynomial with x minus 1, you got the quotient as the other factor, x minus 3. Tell me if you can find the other 0 of this polynomial or not.
Yes.
Very simple, right? We used to do factorization to get this one.
Yes, sir.
Earlier, we used to do factorization to do this polynomial, to get to this stage. But now we have done the same thing, same factorization using simple division. Okay. So x minus 1, we already knew that this x equal to 1 was one of the zeros. But from the other factor, I have got that x minus 3 equal to 0. That means x is equal to 3. So one of the zeros, alpha is 1, beta is 3. I could find both the zeros using simple division. Tell me if that makes sense, everyone. Anyone wants me to repeat this, revise this, anything? Or you got it? Guys?
That's it. Yes, sir.
No need to hesitate, okay? If anybody has not understood, you can ask me any number of times. No need to hesitate. Ask me. Is it clear? Okay.
Sir, this way no sir, but what to do if the power is 4, sir?
Yes, we'll get to that. Okay, that's good. Very eager to solve the difficult question. Let's get to that then. Okay. Yeah. So the one which we solved, it was very easy. And actually that problem, because it was quadratic problem, we could have solved it without doing all this division. We could have very simply used the splitting the middle term, and we could have found the two factors, and we could have done the two zeros. No problem there, right? We know how to do factorization for quadratic polynomials like this. But this division method becomes even more important for polynomials like which are cubic and quartic like this, degree 3 and degree 4 polynomials, because we don't know how to factorize it directly. Do you know how to directly factorize into simple factors like that? No, right? No one knows as of now to directly factorize. Some problems may be easy to do that, but most of them will not be easy just to factorize on their own, just like that. Okay, it's not easy to do that. So this division method becomes important. And in all this, what I was trying to tell you, that whenever you have the zeros, like if alpha is one of the zeros and beta is another zero, means you can say that x minus alpha is one of the factors, x minus beta is another factor. This is one of the factor, this is another factor. Let me tell you the same thing in terms of numbers, not without using alpha and beta. So let's take the same problem. What are the two zeros given here? Root 2 and minus root 2. So root 2 is one of the zeros and the second one is minus root 2. So now what will be my factor of the given polynomial? What will be the factor of this polynomial? It will be
X minus root 2, x plus root 2.
Yes, x minus root 2 and then x minus again minus root 2. So this turns out to be x plus root 2. Remember, what did I say? X minus beta, right? So x minus, this is your beta, which was already negative. So minus and minus become plus over here. Now we have got the two factors of this polynomial. What are the two factors? X minus root 2 and x plus root 2. Combine them together, multiply them together like this. So we can say that this is a factor of given polynomial, right? This is your given polynomial px. So what we will do, since this is in the factor form, I want you to simplify it, write it in the normal polynomial form. Multiply these two, what will happen? Simplify and tell me. A minus b into a plus b. When you simplify, what does it become?
X square minus root 2.
Sir, x square minus
Minus
4.
2.
X square plus 4, sir.
X square minus 2, sir.
X square minus 2, sir.
Sorry, sir. X square. Sir, it will be plus 2, sir.
A square a minus b into a plus b will become a square minus b square. No? So x square minus root 2 ka square. That means x square minus 2. Okay?
Yes, sir.
This minus will be outside the square. So don't make that, put it inside. Okay? It will be x square minus 2. Everyone is okay with this? So I'm saying that x square minus 2 is a factor of this given polynomial. So if I divide my polynomial px with x square minus 2, then I will get the remaining factor. So let's do that division. X square minus 2 will be the dividend and divisor, and this will be your dividend. 2x to the power 4 minus 3x cubed minus 3x squared plus 6x minus 2. So I want you people to do the division. Complete the division and tell me what is the quotient and what do you think the remainder will be when you do the division?
0, sir.
Yes, very good. It will be 0 because we already know that. How did we get this x square minus 2? Using the zeros, root 2 and minus root 2. So if these two are the zeros, means this guy x square minus 2 will be a factor, and if it is a factor, remainder will always be 0. So we already know remainder is 0, just find the quotient and that will be our remaining factor. So do that. Let's see who does it before me. I will start after 1 minute. I give you head start of 1 minute.
Sir, completed, sir.
Okay, that's good. Hold on. Let me just complete it and then we'll match the answers. Okay.
Sir,
Yes.
so why did you leave that minus 3x cube?
See, when you multiply this 2x square with 2, what are you going to get? You're going to get a square term only, right? So you have to write always like terms below the like terms. X square के नीचे x square लिखना है. You have to write x square below x square. You should not write it over here. Yeah. Here you have x cube term, right?
Sir,
Tell me.
sir, for me I'm getting remainder 0, sir. But at the same time, when I get remainder 0, I'm having 6x minus 3x cube plus 6x remaining, sir.
I'm not getting it, sir. You got the remainder 0, but what is then? Quotient you're getting something
No,
else?
sir. No, sir. Now while dividing, sir, now 3x is remained like that only, no, sir. Sir, that 3x cube we should put it in this last, no, sir.
This you should put it in the last. No, you should always write it in the decreasing order of the power, like this. First you will write
Yes,
the
sir.
x
Yes, sir.
cube
That
term.
mistake I did, sir.
Yeah, x cube you will write below x cube, then x square, then x, and then constant term like this. You will always write, even while doing this process, even in the second stage also or third stage, wherever you are, you should always write it in decreasing order of power like this. Okay. So everyone is okay with this step, or should I write it more clearly? Hold on. Okay. Right. So what should be our next step? X square and then x cube. So what do I have to multiply to make it 3x cube? I'll have to make minus 3x, so that it becomes minus 3x cube. And then minus 3x into 2 will become plus 6x. So as you can see, this plus will become minus, minus will become plus. So both of these become 0. What's remaining? X square and minus 2. So you can, yeah, write it like this, square minus 2. Now what do I have to multiply to x square to get x square? Of course, it is just a 1. So x square into 1 will become x square, and 1 into minus 2 will become minus 2. Change the sign again. This is also 0. This is also 0. So our remainder has become 0, and this is our quotient. Okay. Now, very important thing you should understand is x square minus 2 was one of the factors, and the remaining factor is this. What does it mean? It means that whatever polynomial, the big quartic polynomial which was given in the question, it can be written like this.
Sir, I got the remaining two zeros, sir. Alpha is 1 by 2, beta is 1, sir.
Let's see that. That's good. So whatever that polynomial was given, now you should be able to write it as x square minus 2. It was one of the factors. And what is the other factor we just now got in the quotient? 2x square minus 3x plus 1. Okay. So let me write the whole thing also. X to the power 4 minus 3 correct? Plus 6x minus 2. Okay. So this was the given polynomial. And how did we find this x square minus 2? Everyone remembers that? How did we get this x
Yes,
square minus
sir.
2? Using the two zeros, square root 2 and square root minus 2, minus square root 2. From that, we got this factor. And how did we get this factor?
We will be finding factors of this second one.
Yes, once now you simplify it, since it is in quadratic form right now, I can't directly get the remaining two zeros. You simplify it further. This is just a quadratic polynomial. You know, you can use the splitting the middle term method and find the two factors of it. And using that, you find the remaining two zeros. So I will do that for you. You people also follow this, who would not understand. Okay. So this, to complete what I was saying, x square minus 2 has come from the given zeros. From the given zeros, which was root 2 and minus root 2. This helped us to find this x square minus 2. And then we divided it and we got a quotient. That is our second factor. Now what I'm going to do, I'm going to take this second factor over here, this one, and do the splitting the middle term method to find the remaining two factors. 2x square minus 3x plus 1. So how should I split it? There's a 2 here, there's a 1 here, so it will be 2 ones are 2. And the factors will be, of course, 1 times of 2. This is the only factor. And both of them should be negative, so it should be minus x and minus 2x. That is how this will get split up. Okay. And take the 2x common, so it will be x minus 1. And then take minus 1 common, so it will become x minus 1. X minus 1 into x minus 1. Is everyone able to get to this stage? From here, this is just splitting the middle term.
Yes, sir.
If anybody needs help with this, you need to let me know. I'll explain that. Okay. So, what are the two remaining zeros now? If 2x minus 1 equal to 0, it means that 2x is equal to 1, so x is equal to 1 by 2. This is one of the zeros. And the other zero, if x minus 1 is 0, then x is equal to 1. Okay. So what are the four zeros? So the zeros of the given polynomial are root 2 minus root 2. These two are already given. And what did we find out? 1 by 2 and 1. So these are all the four zeros. Okay. Okay, so this may be a little complicated for some people. It's all right. No need to worry too much. Just go through the recording 1 or 2 times and try to understand. If you have any doubts, I will explain this again in the next class. Okay, get comfortable with this one. And those of you who have understood how to do this, we'll start working on the exercise 2.3. In fact, everyone can start working on 2.3, at least whichever questions. Like first question is very simple. Finding the quotient and remainder by doing simple division. Check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by first one. Do you people know how to do the second question? I don't think we learned it, but can you do it on your own? I have not taught you this one right now, but can you apply whatever we learned so far to solve the second question?
Sir, there is only
Sir.
one polynomial. So what is the second
Sir,
one?
if the remainder is 0, then it will be a factor.
Yes, very
Yes,
simple.
sir.
That's good. If If we do the division, if
Sir.
the remainder turns out to be 0, then it will be a factor. Yes, Charan, go ahead.
The second one, they are telling whether it is the polynomial is divisible by first one or second one, sir.
No, no, no.
We don't even have the second.
No. They are saying check whether the first polynomial is a factor of the second one.
Second one means that the second question again on the full question, sir.
No. Each question for each one. Let's say when you take the first one, you see there's a comma over here, no?
Ah, yes, sir.
So this is your first polynomial. This is your gx,
Yes,
and
sir.
this is your px. So you have to say whether px gx is a factor of px or not. So
Sir, using long division, we can find, sir, if the remainder is 0, then it will be a factor.
Yes, we will do simple division, long division, and we'll see whether the remainder is 0 or not. If the remainder is 0, means t square minus 3 will become a factor of this polynomial. Okay, so everyone knows how to do the second question also. Anybody has a doubt in second question? Anyone needs explanation, let me know. No, don't hesitate. Just because other people have understood doesn't mean that you should be okay with it. They are not going to write a board exam for you. These are important questions. Make sure you understand it. Okay, fine. So if you have understood, you will try this question number 1, 2, and third one also. If you have understood today's class, this is the one which we did in today's class. Obtain all the zeros if 2 of its zeros are given. These two. Very same question which we did just now. Okay. So I want you people to work on this. This is your assignment. Exercise 2.3. Question number 1, 2, 3. That's all. Fourth question and fifth question I'll explain in the next class. So basically question number 1 and 2 are from the previous class itself, simple division. Okay. Third question is the one which we learned today. So go through the recording of today's class also and try to do this. So that's it for the maths class, guys. Anybody has any questions? Let me know.
Sir, fourth one is also simple, sir. But here they have given, they did not give the dividends, sir.
Yeah.
We should
That's
find
very,
the dividend.
yes, of course. That's also simple. If you already know how to solve it, then you can do that also. Okay, that's good. If you can solve that also, that's very
Yes.
good. So anyone has any questions?
Sir,
Yes, Madam.
sir, from yesterday's class, sir, that verification, how we are multiplying that both polynomials, sir, that one I couldn't understand.
Okay, just a minute. Let me start the timer for other people. Rest of the people can go on a break for 10 minutes. And maths class, that's it for maths class today. Okay. Science people will join back in 10 minutes. Yes, Medul. Try to tell you question again. Clarify. I couldn't understand what you were asking exactly. You want me to go
How
to
we
the
are verifying?
how we are verifying? Okay. So this is the notes from the previous class. So this division part you understood how to do the division?
Yes, sir.
Okay. So once you understand this part, yeah, let me tell you from the beginning. you should know that this is the dividend, which will be your polynomial px. Okay, whatever polynomial is given, the big one, that will be your dividend, and you will be dividing it with the divisor gx. Okay, you get the quotient qx and remainder rx. So are you comfortable with these terms? Px, gx, qx, and rx. These terms, are you comfortable with?
Yes, sir.
Okay.
Yes. So this one all I understood, sir. But how we are multiplying the both polynomials? That alone I couldn't.
Okay. So like for example, when you wrote it like this during verification, px is equal to gx into qx, and then you are asking me how to multiply these two. Is that your question?
Yes, sir.
Okay, multiplying polynomials is very simple. You have studied this in your earlier classes also. So what you have to do is you have to multiply one by one. You take this x. Hold on, let me change the color. So you take this x first and multiply with 2x. What do you get? You get your 2x square. Tell me if you got understood that, how that came. X into 2x becomes.
Your voice is breaking.
Okay, can you hear me now? Is it clear?
Yes, sir.
Okay. So what I'm saying is you take your first polynomial, first term here, x, and you multiply with the first term 2x. X into 2x, how much that becomes?
2x square.
Yes. Constant will be 2 only, and x into x becomes x square. So this is what we have written here as 2x square. X into 2x becomes 2x square here. Up to here it is clear?
Okay, sir.
And then what you do?
Yes, sir.
Then you take the same x and multiply with the second term, that is minus 1, x into minus 1. X into minus 1, how much that will become? Minus x.
Minus x, sir.
You see that minus x I have written here.
Yes, sir.
Okay. What did we do? First x with 2x, then x with minus 1. So that gave us these two terms. Then what we do? We take this 2 now, the second term from the first polynomial, and again do the same thing. 2 with 2x will give us 4x here. 2 into 2, 4, and then x. Okay, right?
Yes, sir. Yes, sir.
Then 2 with minus 1 will give you minus 2. So that way you got these two terms. So binomial into binomial gives you a 4-term polynomial like this. But you'll be able to simplify it further. 4x minus x becomes 3x. Okay, but this 3 was as it is written, just like that. 3 and 3 was written as it is. No need to do anything. And then when you have all the like terms, so this 2 minus 3, they are like terms, they will become simplified, they'll become plus 1. 4x minus x becomes 3x. So that is how we did the multiplication.
If we are having like terms, we can simplify it now, sir.
Yes, like terms should always be simplified. We have to do that. If you don't do it, will be wrong. Wherever
sir.
there are like terms, you have to always simplify it. Always do the simple addition, subtraction, whatever, based on the sign. Okay. So this was binomial with binomials.
Yes,
even when you have bigger polynomials, like this one, as you can see here, in this verification, what is happening? We have a trinomial here and we are multiplying with a binomial. Same thing you will do, x square with 3x, then x square with 5. You will get these two terms. Okay. Then you will take this 2x.
Yes, sir.
2x with 3, 2x with 5, then you will get these two terms. And then you take this 1 and you will multiply 1 with 3x and 1 with 5. You will get these two terms. And 9x plus 10, I have written as it is. Okay. So now you go through today's video also. The explanation what I'm giving right now, that is also being recorded. So you will be able to see this explanation also. And you can go through these notes again. And
Okay, sir.
try to do all this again on your own. Okay.
Okay, sir.
Right.
Thank you, sir.
Yeah. So I think the break is almost over, but whatever it is, just go drink some water, freshen up, and then come back for the science class. Okay.
Okay, sir.